Hello to all Constructive Minds followers. I'm Theodore, and today we're about to embark on an incredible journey to the heart of Europe. A place where engineering, precision, and innovation merge into one common language, Germany.
Hello, I'm Eleanor, meaning shining light. Theodore, today we are not just going to talk about a few ordinary buildings. We are going to unveil the secrets of Germany's megastructures, masterpieces that compel every structural engineer to pause and think deeply.
Exactly. When we say Germany, the first things that come to mind are probably quality, discipline, and efficiency. But the three buildings we've chosen go beyond ordinary quality. They posed challenges for the construction industry that remained controversial long after their completion.
Take the Elbphilharmonie in Hamburg, for example, a concert hall that is unique not only for its unparalleled acoustics, but for that peculiar box-in-box concept with 680 steel springs that completely isolate the hall from environmental vibrations.
Or that crazy floating cloud roof idea at the BMW Welt in Munich, a massive spatial truss that manages all loads with minimal internal columns. Architectural daring made possible only by German engineering.
And of course, the Berlin TV Tower, Fernsehturm, a relic from the Cold War era, which, using the jack-up technique to lift the 4,800-ton restaurant sphere, pushed the boundaries of construction execution at that time.
On our YouTube channel, we've compared the construction industries of many countries around the world, like the US, China, Spain, and Singapore. Which country do you think has the craziest buildings? After watching this video about Germany, your mind will definitely change.
So stay with us for an in-depth expert analysis of how these megastructures managed to defy the laws of physics and structure. If you love unusual structures, engineering analysis, and bold architecture,
then subscribe to the Constructive Minds channel right now and hit the bell icon. Don't miss any exciting episodes. Let's go into the heart of German engineering.
So when I say German engineering, what pops into your head? Probably precision cars, right? Maybe some advanced machinery? Well, behind that famous discipline are these architectural masterpieces that don't just look incredible, they actually solve engineering puzzles that once seemed completely impossible. We're gonna decode the genius behind them. And here's the thing you've gotta get. We're not just looking at cool buildings. We're looking at solutions. Every single structure we're going to talk about today is an answer to a really unique challenge. It's physical proof of how to overcome the limits of science and materials. They're bold, they're audacious, and you know what? They're a little bit strange, in the best possible way. So let's meet the three main characters in our story today. First up, we're in Hamburg to check out a concert hall that basically floats. Then we'll head down to Munich to deconstruct a man-made thunderstorm of steel. And finally, we'll take a trip back in time to 1960s Berlin to see how engineers built a socialist space needle. All right, first stop is the Elbphilharmonie in Hamburg. I mean, just look at that thing. It's this magnificent, wave-like glass structure that looks like it's sailing right on top of an old brick warehouse. And while it looks incredible on the outside, the real magic, the real genius, is hidden deep inside. And that brings us to the core puzzle. See, the Elbphilharmonie is sitting right in the middle of a super busy port. We're talking constant noise and vibrations from massive ships, cranes, city traffic, the whole deal. So the question is, how on earth do you create a space for world-class acoustics? I mean, a place of perfect silence, right in the middle of all that chaos. Well, the answer is this absolutely incredible piece of engineering they call the box-in-box system. And what's so genius about it is that the concept sounds simple, but actually pulling it off, that's where things get complicated. Just soundproofing the walls was never going to be enough to stop those deep vibrations from the ships. So instead, they designed the entire concert hall as one massive shell that doesn't physically touch the rest of the building. It literally floats inside that huge glass structure. So how does it float? Get this, it's resting on 680, count them, 680 enormous steel springs. Think about that for a second. Each spring is an engineering marvel on its own, built to handle the unbelievable weight of a 2,100-seat concert hall. And together, they soak up every single vibration from the outside world, from a passing container ship to the rumble of a train. It's just a brilliant solution, right? You're basically creating this little pocket of perfect silence, right in the heart of a noisy city. All right, let's head over to Munich for our second puzzle, the BMW Welt. People call it a floating cloud, a structural thunderstorm, and you can see why. It's designed to feel like pure motion and tech. It's this huge, wide-open space with a roof that just seems to defy gravity. So here's the big question. That roof is made of 16,000 tons of steel. Let that sink in for a second. Now, in any normal building, a roof that heavy would need a whole forest of columns inside, just cluttering up the space. But the vision here was for something totally open and fluid. So how in the world did they pull it off? The secret? It's all about something called the double cone. Think of these two twisting vortex-like towers as the hidden giants of the whole building. They're the secret backbone. They carry all that enormous weight from the roof and channel every single force, from gravity to wind, safely down into the foundation. And they do all that while looking like these incredible sculptures. Okay, so this is where you can really see how groundbreaking this was. You know, a normal building, it's got a bunch of columns holding things up. Simple. But the BMW Welt uses this complex, three-dimensional steel web for its roof. And this isn't just for looks, you guys. It's a totally different philosophy of how to handle weight, one that chooses open space and dynamic shapes over just simple, boring support columns. Okay, for our last puzzle, we're going to jump in a time machine and head back to 1960s East Berlin. This is where a project that started out as a big political statement ended up becoming one of Germany's most iconic engineering marvels, and, funnily enough, a beloved symbol of the unified city, the Fernsehturm, or the Berlin Television Tower. And the challenge here, it was just sheer audacity, especially for the 1960s. The plan was to stick this huge steel sphere, which was actually inspired by the Sputnik satellite, near the top of a really skinny concrete tower. That sphere weighs 4,800 tons. So seriously, how on earth, with the tech they had back in the 60s, do you get something that heavy 200 meters up in the air? The way they did it was just an ingenious three-step process. First, they built the concrete shaft really, really fast, using a method called slip forming, where the mold just keeps moving up. Now, while that's going on, they built the entire 4,800-ton sphere on the ground, right at the base of the tower. And then, and this is the masterpiece moment, they used these powerful hydraulic jacks to slowly, carefully lift the entire sphere up the shaft. It was just an absolute feat of planning and execution. Incredible. So the final result is this structure that stands, get this, 368 meters tall, which makes it the highest building in all of Germany. And that massive scale, that was the whole point, really. It was meant to be this huge symbol of socialist power and technology. But today, it's totally gone beyond that history to become a true icon of Berlin for everyone. Okay, so when you step back and look at all three of these structures together, something really fascinating starts to emerge. They're not just cool one-offs, no. Each one represents a totally different way of thinking, a different philosophy for solving huge engineering problems. They tell a story about how things have evolved. And this table here, it lays out that evolution perfectly. You've got the fancy term from the 60s, which is all about raw power and a kind of elegant simplicity. Just get it up there, make it strong. Then you fast forward to the 2000s with the BMW Welt, and the philosophy is all about creating dynamic shapes and fluid geometry. And then you get to the Elbphilharmonie, which is the absolute peak of performance-driven design. It's all about precision, about getting that one perfect functional result. And their legacies go way beyond just the blueprints and the steel. So the Elbphilharmonie, for example, with all its budget and timeline issues, it ended up teaching some really tough but important lessons about managing these massive public projects. The BMW Welt pushed what was possible with steel and inspired a whole new generation of architects to think more fluidly. And the Fernsehturm, which was once a symbol of division, has been totally embraced as a symbol of a united Berlin. So, where does all this lead? Well, the future of this kind of engineering is shifting beyond just being stable. Now it's about making buildings that are not just strong, but also super energy efficient, flexible in how they're used, and able to stand up to things like climate change. We're talking digital twins, modular construction, and much, much smarter materials. At the end of the day, each one of these masterpieces totally redefined what was possible for its time. They took a challenge that seemed completely insurmountable and came up with an elegant, powerful solution. And it just leaves you wondering, right? What are the impossible challenges that today's engineers are staring down? And what incredible, mind-bending buildings are they going to dare to create for us next?
The analysis of these 3 German structures was truly astonishing. We saw how engineers found a bold solution for every challenge, whether it was for acoustics at the Elbphilharmonie or for load transfer at the BMW Welt.
Indeed, these projects are prime examples of how precision and audacity can overcome any technical limitation. Remember, at the beginning of the video, we asked you, which country do you think has the world's craziest buildings?
Now that you've discovered the secrets behind these German megastructures, you can give us a more precise and engineered answer. Be sure to write your opinion in the comment section and compare Germany with other countries.
We at Constructive Minds promise to challenge you every week with more in-depth analyses.
This content was produced by the Constructive Minds YouTube channel. If you are interested in deep and engaging videos about construction and structures, subscribe to our channel, hit the bell button so you don't miss the next video, and if this video was useful to you, share it with your engineer, architect, or construction enthusiast friends. Until the next video, goodbye!